Coming to our lesson, and hope you will enjoy as we continue to discuss our topic today. In our discussion today, we are looking at the topic differentiation. We are looking at Form 4. We are looking at Form 4 mathematics. Form 4 mathematics. And our topic of discussion, students, is differentiation. Our topic is differentiation. Our topic of discussion today, students, is differentiation. This is a Form 4 topic on calculus that we need to summarize in our lesson today to understand what are the concepts that we have to emphasize on while we are revising on the topic differentiation. And as I said, our discussion is going to be based on two items. One, we want to look at the determination of gradient of a curve at a point. We will discuss or review determination of gradient of a curve at a point. And number two, students, we are going to look at what we call the turning points. So we shall look at the tangent, and the normal, and then we shall extend further on this one to look at the turning points of a curve. Therefore, students, by the end of our lesson today, we will need to be able to have an outlook of what we've presented on the board as our main areas of discussion in our lesson. But before we look at each of them, students, it's important that we understand one main thing, and that is what we call the process of differentiation. In the process of differentiation, how do you differentiate polynomial, students? What do you do when you are differentiating, students? Yes, we have to look at the power of the variable or the component x, and then we multiply by the coefficient. Good. What we mean is a general expression y is equals to ax power n. A general equation y is equals to ax power n is the equation of a polynomial representing the equation of a curve. How do you differentiate? We take dy dx, and we've said we will have n multiplied by a. That gives us an, then x, we subtract 1 from the power. Good. We take n less 1. Good. This is the process of differentiation that we need to understand even before we look at what we have presented as our key areas of discussion in our lesson today. First of all, students, we looked at this as a curve. If this is a curve, that is represented by the equation y is equals to ax power n. Various units. We can use any 2 points to determine the gradient along this line, and it will be the same gradient. What do we mean? For example, assuming the gradient between these 2 points is 2, then these 2 points will give or along the whole curve. But at a particular given point, there has to be a given point on which you are determining the gradient. So let's say, for example, we could have a point here, A. If I'm to determine the gradient of this curve at point A, and point B, point C, point D, and point E, the gradient will be different. It will be different, and that is why we have to be very careful that when we are doing this, we have to represent this by drawing lines along at the given points, what we call the tangents. So I will draw that as the tangent 2. At C, I will also draw a line. And equally will be if we draw a line at D. We will draw the line at D. So later on in our discussion, we will be able to realize that those lines are called tangents. But we draw them for us to be able to know that we need to have a straight line passing through a given point on the curve before we can tell what is the gradient of the curve at that particular point. Therefore, students, in our first item of discussion today, what we are saying is to determine the gradient. If you are to determine the gradient, of a curve at a point, then the first thing will be differentiate. You find the dy dx. You differentiate to find the dy dx. And in this concept, what we refer to this as dy dx is called the gradient function. We call it the gradient function. And you will find the gradient function is in terms of x. Then number 2, you replace the value of x at the given point in the gradient function. And when we do this, what do we do to obtain the gradient? So we have to replace the value of x at the given point in the gradient function purposely for us to obtain what is the gradient of the curve at that point. Therefore, students, what we are saying is that there are 2 steps we shall need to undertake when we are determining the gradient of a curve at a point. Step number 1 will be to determine what we call the gradient function, what we call the dy dx. And number 2, we'll have to replace the value of x at a given point in the gradient function to obtain the gradient. Let's look at an example. Determine the gradient of a curve y is equals to 3x squared plus 4x minus 5 at the point 2, 1. We determine the gradient of the curve y is equals to 3x squared plus 4x minus 5 at the point 2, 1. Students, what do we do? Good. The first thing that we do is to find the dy dx. So let's differentiate dy dx. It will help us differentiate the function y is equals to 3x squared plus 4x minus 5. Yes, the first thing to do, we take 2 times 3, that is 6x. Then we less 1 from the power, so we have power 1 plus, what is the derivative of 4x? Good, the derivative of 4x is 4. What about 5, negative 5? 0, yes. So whenever you differentiate constant, students, you will always get 0. Therefore, our function y is equals to 3x squared plus 4x minus 5 differentiated gives us 6x plus 4. What is this function? We are referring to it as the gradient function. That is referred to as the gradient function. Good. At a defined point 2, 1, at the point 2, 1, what is the value of x, students? What is the value of x, students? Good. The value of x is 1. Sorry, x is 2. Value of x is 2. Therefore, our gradient is equals to 6. Where there is x now, replace it with 2. Where there is x, replace it with 2. So we have 2 plus 4. Good. What is 6 times 2, students? 12. 6 times 2 is 12. Add 4, that gives us 16. Good. Our answer is 16. Therefore, it implies that the gradient of the function y is equal to 3x squared plus 4x minus 5 at a specified point 2, 1 is 16. Is that correct, students? Good. The value is 16. So let's look at our example number 2. Let's look at our example number 2. Determine the gradient. Determine the gradient of a curve. Determine the gradient of a curve. Y is equals to 1 over 3x power 3 less 2 over 3x squared minus 5 over 7x plus 1. We determine the gradient of the curve at the point 0, negative 1. At the point 0, negative 1. Determine the gradient of the curve. Y is a third x cubed less 2 over 3x squared less 5 over 7x plus 1 at the point 0, negative 1. At the point 0, negative 1. Students, so let's discuss it together and get the gradient. Fine. What is the first step? Students, what's the first step? dy dx. What's the dy dx? Good. A third x cubed. If you differentiate that part, you will have x squared. What is the derivative of 2 over 3x squared, students? Good. That will be 4 minus 4 over 3x. What do you get when you differentiate negative 5 over 7x? Good. It is negative 5 over 7. What about the derivative of 1? We've said the derivative of constant is always 0. Therefore, we will not strain writing anything there. We'll have x squared minus 4 over 3x minus 5 over 7. The question is specific. At the point 0, negative 1. At the point 0, negative 1. What is the value of x at this point? Good. The value of x is 0. So our gradient, therefore, our gradient will then be equal to, we replace in this gradient function, so it will be 0 squared less 4 over 3 into 0 less 5 over 7. Those who have calculators, what do you have? This is 0 less 5 over 7, implying our gradient is negative 5 over 7. Our gradient is negative 5 over 7. For the curve, y is equals to a third x cubed minus 2 over 3x squared minus 5 over 7x plus 1. Good. So that is the first thing, student, that we wanted to discuss, to form the foundation of what we want to discuss further, which is the determination of the turning points of a curve. We need to look at the turning points of the curve. And in the describing turning points, I will illustrate this using this curve. Assuming that we all have this as our curve. This is our curve. We'll call it curve A. This is our second curve. I will label this as our curve B. And then I'll have this curve. This one, I'll have it as curve C. You'll realize that as you draw these curves, they are taking different shapes at different points. The curve A is drawn curving downwards and turns at this point. So I'll call this one point, let's say point X. If we are to draw this on a Cartesian plane, assuming that we have the x-axis, I will define it to be below the x-axis. In curve B, I have a turning point Y. A turning point Y. And in C, I have different turning points. I have at this point, the curve turns, and again, when it's moving upwards, it turns. So let's call this one A, and let's call this one B. As curves turns, the specific points at which a curve turn is referred to as the turning point, or the stationary point. And there are different types of turning points that we will need to discuss. A curve can either have a maximum point, a minimum point, or a point of inflection or inflectionary turning points. The one that turns low, at the low point, this one is minimum, and this gives us the maximum, while this is an illustration of an inflectionary point or a point of inflection. But what is key, student, is to understand one basic concept in turning points. And what is that concept, students? When you're discussing turning points, or stationary points, at every turning point, the derivative, the dy dx is always 0. So whenever you are given a question and you are asked to determine the turning point, then what you need to do is differentiate the function and equate to 0. Differentiate the function and equate to 0. In this case, we've seen how to differentiate, because that is what we started with. We have seen how to differentiate to get the dy dx. Then once you've found the dy dx, equate it to 0, you will get the turning point. Example. So students, let's take this example. You are told to determine the coordinates of the turning point of the curve y is equals to 2x squared plus 4x less 6. We determine the coordinates of the turning point of the curve y is equals to 2x squared plus 4x minus 6. Students, where do we start from? Yes, the first thing to do is to differentiate. Good. So will help us differentiate this curve. What's the dy dx? Yes, it will be 2 times 2, that is 4x, then plus the derivative of 4 x is 4. And now, its turning points. What do we do? At the turning points, dy dx is equals to 0. At the turning point, students, dy dx is equals to 0. So we shall have 4x plus 4 equal to 0. 4x plus 4, students, is equals to 0. Good. Now, how do you get x, students? Take 4 to the right side, becomes negative. So 4x equal to negative 4. What is x? Good. We divide by 4. Divide by 4. What is negative 4 divided by 4, students? Negative 1. Good. So the answer is negative 1. The answer is negative 1. Therefore, when you differentiate the function y is equals to 2x squared plus 4x minus 6, we get 4x plus 4. And since the question is about the turning point, we equate the dy dx to 0 to obtain the value of x as negative 1. Remember, the question is about coordinates. A coordinate is defined by x and y. Therefore, we have to get what is y. How do you get y, students? Right. What we do is we take the value of x and replace in the initial function for the curve, which defines y. So we are saying, but y is equals to 2x squared plus 4x less 6. Now replace in x as negative 1. So we'll have 2 into negative 1 squared, add 4 into negative 1, less negative 6, less negative 6. Good. Let's work it out. What is negative 1 squared? It's 1 times 2, that is 2. 4 times negative 1, negative 4, less negative, that is less 6. So it means that our y is defined by negative 8. Our value for y is negative 8. Therefore, how do we write the coordinates? Our coordinates will be negative 1, comma, negative 8. That is the turning point. Therefore, whenever you're given the turning points, that is how we work out the turning points of the curve. So let's get now one of the questions that was done in the previous exams. The first question, which was done on the turning points. Let's see, students, what is the first question that we have on the turning points. Let's be able to have our question on the screen for the turning point. The first question. Students, we are saying one thing before we move on, that the turning points are obtained by first differentiating the function, what we call the dy dx. Then once we have the dy dx, we now substitute in the value of, we now equate the dy dx to 0 and find the value of x. Once we have the value of x is x equals to negative 1, we now replace it into the function defining y, which is y is 2x squared plus 4x minus 6. And so where there is x, we substitute negative 1, negative 1. And this gives us 2 minus 4 minus 6 to get negative 6. And so our y is negative 8. Therefore, minus 1 minus n defines the value of the turning point. So we can look at other examples. We can look at the other example, number 2. Number 2, determine the equation, the coordinates, determine the coordinates of the turning point, points to the curve, y is equals to a third x cubed plus 5x plus x squared that is 3x squared plus 5 is equals to 0. We have a third x cubed plus 3x squared plus 5 is equal to 0. Plus 5 is equals to 0. Yes, the first question. So we can have it. So students, you'll work out this as we work out now this question on the screen. The first, yes, that one. That is in the KCSE 2019, question number 7. For students, if you've been able to look at that question in the previous exams, you'll have seen the question, find the coordinates of the turning point of the curve y is equals to x squared minus 14x plus 10. Y is equals to x squared minus 14x plus 10. 2019 KCSE question number 7. We need to get the turning points. Where do you start, students? Yes, the first thing to do is to differentiate the function of the curve. So let's differentiate our solution. Dy dx equal to, if you differentiate x squared, what do you have, students? 2x. Differentiate 14x, students. Negative 14. Good. We have negative 14. Next step, yes, we equate the dy dx to 0. At the turning point, the dy dx is equals to 0. At the turning point, the dy dx is equals to 0. Therefore, we have 2x less 14 is equals to 0. 2x less 14 is equals to 0. Take negative 14 to the right side, students. We'll have 2x is equals to 14. 2x is equals to 14. So how do you get x? Good, you divide by 2. So x is equals to 7. X is equals to 7. And now we get the value for y at the point x is equals to 7. So what do we do, students? We say, but y is defined by x squared minus 14x plus 10. So it will be y is equals to, x is 7. So we'll have 7 squared minus 14 into 7 plus 10. What is 7 squared, students? Good, 49 minus 14 times 7, students, 98 plus 10. 98 plus 10. 49 minus 98, negative 49, plus 10, negative 39. Therefore, what is the point? Our turning point is 7, negative 39. 9. Our turning point is 7, negative 39. Once we've understood clearly how to find the equation, the turning point, students, you'll be required again to know how to identify the nature of turning points. How do you identify the nature of turning points? The nature of turning points. Turning points. Once you've determined the points, you may be asked to get the nature of turning points. And the simplest way to get the nature of turning points is simply to differentiate the function twice. So you find the derivative dy dx, and then obtain the second derivative with respect to x. And in the second derivative, you replace the value of x, you replace in the value of x. If the result that you get is negative, if you get a negative solution, students, it means the point is minimum. The point is minimum. If you get a positive solution, then it implies that the point is maximum. The point is maximum. So what do we mean in this case? We've already determined our point as 7, negative 39. I want us to use it just as an illustration to show whether the point that we have is maximum or minimum. When we differentiated our functions, if you differentiate our function using the example, this is the example, we have determined the nature of turning points, of the curve y is equals to x cubed plus 2x squared minus 6x plus 7 minus 6x plus 7. We determine the turning points, the nature of the turning points of the curve y is equals to 3x cubed plus 2x squared minus 6x plus 7. Students, what we are going to do is as described here in our illustration. We'll first find what is the turning point. So how do we get the turning point? dy dx. Our dy dx is 3x squared plus 4x, then minus 6 plus 4x minus 6. Then we take 3x squared plus 4x minus 6, we equate it to 0. We equate it to 0. So what will be x, students? X will be equal to, we apply the quadratic formula, minus b plus or minus the square root of b squared minus 4ac over twice a. That is the formula. Where there is b, we replace with 4. Where there is a, we replace with 3. Where there is c, we replace with negative 6. So this will be negative 4 plus or minus the square root of b squared. 4 squared is 16. Then plus, why plus? Because our sign here is negative and c is negative. So it will be plus. 4 times 6 is 24 times 3, that is 72. 72 over 2a, that is 2 times 3, 6. 2 times 3 is 6. 16 plus 72, that gives us 88. That is 88. So we have negative 4 plus or minus the square root of 88 over 6. Square root of 88 over 6. If you work out what is the value of x, negative 4 plus or minus the square root of 88, 9.3. 9.3, we divide by 6. We divide it by 6. So we'll have x equal to negative 4 plus 9.3 over 6, or x is equals to negative 4 minus 9.3 over 6. So we have the two values of negative 4, when you have now negative 4 plus 9.3, negative 4 plus 9.3, so we have 9.3, then we divide it by 6. We divide it by 6. So we shall have 6, 9.3, we divide it by 6, we get 0.9, rounded off to 1 decimal place. Then the other side we have negative 4, that gives us negative 13.3, 13.3, divide it by 6, 2, x is equals to 2.2. X is negative 2.2. So those are the two values for x. X as 0.9 and x as negative 2.2. But these are not complete points. So what do, students? We replace them in the function for y. And this is the function for y to get what is y. So in this first case, y will be equal to x cubed, that will be 0.9 cubed, plus twice into 0.9 squared, less 6 into 0.9, add 7. We add 7. So students, again, let's take our calculators and do the substitution. We have 0.3 cubed, 0.9 cubed, then we have 0.729 plus 0.9 squared times 2. 0.9 squared times 2, that's 1.62. We less 6 times 0.9. 6 times 0.9 is 5.4 plus 7. 5.4 plus 7. So student, then what's the final solution? 0.729 as 1.62 minus 5.4, and then you add 7. That will give us 3.9. Students, therefore our y is 3.9. Then it means the point is 0.9, 3.9. 0.9, 3.9. That is the value of y. Let's look at the value of y when x is negative 2.2, because we have to get all the 2. So we'll have when x is negative 2.2, we will replace it again in the function for y. So we shall have y equal to negative 2.2 cubed plus 2 into negative 2.2 squared minus 6 into negative 2.2 plus 7. Negative 2.2 cubed plus 2 into negative 2.2 squared, then minus 6 into negative 2.2. So again, let's do the substitution. 2.2 cubed, 2.2 cubed, that gives us 10.648. 10.648 plus, the other side we have 2 times negative 2.2 squared times 2, that is 9.68, plus, why plus? Because negative 6 and the other side you have negative 2.2, so it turns to positive. So we'll have 6 times 2.2 to get 13.2, then plus 7. So put it in your calculator, students, to do the final substitution. That means we have negative 10, that is 9.68, 13.2, and then 7, 10.648. Our answer is 19.2. Therefore, y is 19.2. Now, what is that coordinate? The coordinate, therefore, it's negative 2.2, 19.2. 2.2, 19.2. These are the turning points of the curve. They are the turning points of the curve. But we need to define whether this point is maximum or minimum. Define that point as maximum or minimum. And that's what you've said. To define that, we have to differentiate twice. So our nature of points, nature of turning points, we will now take the derivative. Our function was y is equals to x cubed plus 2x squared minus 6x plus 7. We differentiated the first time dy dx and got 3x squared plus 4x less 6. If I differentiate for the second time, d squared y, d squared x, I will have 6x plus 4. Then I will use this second derivative to find what is the value for the turning points. So when this is the point, at the point 0.9, 3.9, our x is 0.9. Therefore, d squared y, d squared x is 6 into 0.9 plus 4. Work out this one. We have 54, that is 5.4, plus 4, that is 9.4. And this value is a positive solution. It is a positive solution. So what that means, student? It means, therefore, 0.9, 3.9 is maximum point. Is a maximum point. 0.9, 3.9 is a maximum point for the function that we've been given. And finally, the other point, to confirm now the second point, and the point is now negative 2.2, 19.2, x is negative 2.2. Now, what is our second derivative function? d squared y, d squared x is 6x plus 4. So replace in the value of x as negative 2.2 students. So we'll have 6 into negative 2.2 plus 4. If you multiply 6 by negative 2.2 students, what do you get? You get negative 13.2 plus 4. What is negative 13.2 plus 4? Yes, negative 9.2. This value is negative. That value is a negative value, implying therefore that the point negative 2.2, 19.2 is a minimum point. Is a minimum point. So that is the simplest way, students, to determine whether the given points are minimum or they are maximum. They are minimum or they are maximum. And finally, we again discuss about the equations of tangents and the normals. And we say that a tangent is a straight line that meets the curve at only one point, and the point is called the point of tangency. And that is why the determination of the equation of the tangent is done the same way we find the equations of straight lines. So perhaps let's get a second question. Let's have a second question on the screen. Let's have our second question on the screen so that we work out one more example. That is in 2018, KCSE 2018, paper 1. The students or the candidates were asked, the equation of the curve is given as y is equals to, the equation of the curve is given as y is equals to a third x cubed, y is equals to a third x cubed, minus 4x plus 5, minus 4x plus 5. And they were asked to determine the value of y. They were asked to determine the value of y at the point x is equals to 3. Determine the value of y at x is equals to 3. Number 2, they were asked to determine the gradient of the curve. B, the gradient of the curve at x is equals to 3. And lastly, they were asked to find the turning points of the curve. Turning points of the curve. Turning points of the curve. Those were the questions in the KCSE 2018 from this concept that we've discussed today. So let's make a review together, students, so that we see how this question ought to be worked out. Let's work it together. So we'll start, students. The first thing is we have the function of the curve. Y is equals to a third x cubed minus 4x plus 5. You are asked to find the value of y when x is 3. That is very direct. Y when x is 3. It means replace the value of x with 3. So our y will be equal to a third into 3 cubed minus 4 into 3 plus 5. 3 cubed is 9. Sorry, 3 cubed is 27 divided by 3 is 9 minus 12 plus 5. So the answer is 2. The value for y for part A was 2. Did we get 2, students? Yes, so the correct value is 2. Number B. The gradient of the curve at x is equals to 3. The gradient of the curve at x is equals to 3. How do you get the gradient? To get the gradient, we first differentiate. So we find dy dx. So let's get dy dx. This is x squared minus 4. X squared minus 4. Then replace in the value of x as 3. So when x is 3, our gradient is equals to 3 squared less 4. So 9 less 4 is 5. The gradient, student, is 5. And finally, part C, the turning points of the curve. The turning points of the curve. To get the turning points, we've said you get the turning points by differentiating and equating to 0. We've already differentiated. This is the derivative. So at the turning point, dy dx is 0. Therefore, it means x squared minus 4 is 0. Take this to the right side, positive. So x squared is equals to 4. And how do you get x? X is plus 2 or negative 2, because there should be 2 values for x, being that that is quadratic. Then finally, we get the value of y. Therefore, when x is 2, what is y, students? Replace in the function. Y equal to a third into 2 cubed minus 4 into 2 plus 5. So this is 8 over 3 minus 8 plus 5. 8 over 3 minus 8 plus 5. So this is minus 3. And so over 1, and therefore the LCM is 3. 8 less 9. So it's negative a third. Negative a third. Therefore the point is 2, negative a third. Again, when x is now negative 2, what is y, students? Replace in the function for what? For y. So y will be a third into negative 2 cubed minus 4 into negative 2 plus 5. So this is negative 8 over 3 plus 8 plus 5. What is this, students? Negative 8 over 3 plus 13. 13 is over 1, therefore the LCM is 3. That is negative 8 plus 39. Negative 8 plus 39. That is 31 over 3, which is 10 and a third. So what is the point? Negative 2, 10 and a third. And finally, we have to tell, we now get the nature. So how do you get the nature? Nature of turning points. Nature of turning points. We will take the derivative dy dx. Dy dx, we obtained it as x squared minus 4. And the second derivative will be 2x. So when x is 2, what is y? What is the second derivative? The second derivative will be equal to 2 times 2, which is 4, and 4 is a positive. When it's positive, what does it imply, students? It implies, therefore, that the point 2, negative a third, is maximum. And then finally, when x is negative 2, what is the second derivative? 2 into negative 2, that gives us negative 4. This is negative, implying that the point negative 2, 10 and a third, students, is what? Is a minimum point. Is a minimum point. So So those are the areas that we have discussed in our lesson. And just as a review, and as we prepare to show the last two questions as our assignment, we've discussed 4 areas. We've discussed about differentiating polynomials, and we've seen how to differentiate the polynomials. We've discussed again how to get the gradient of a curve at a point by differentiating the function and replacing the value of x in the derivative. And number 3, we discussed about how to determine the turning points of a curve, and then determining the nature of the turning points. So if we could have the last 2 questions now run on the screen as assignment for our students. Yes, so our assignment, students, will be the question from KCSE 2005. As you can see it, the curve has that function, so you are asked to find the dy dx, and number 2, you are to find the value of y at the turning point. That will be your assignment. The second question, the next question, which will be your assignment, will be the one from KCSE